In question number 6, it says that the complex number 2 minus iota is denoted by u. It is given that u is a root of the equation where constants a and b are real. We have to find the values of a and b. Now, if the complex number 2 minus iota, which is represented by u, is a root, so in place of x, we can write this value 2 minus iota. So if you write 2 minus iota whole cube plus a into 2 minus iota whole square minus 3 into 2 minus iota plus b is equals to 0. Now, what we know about this, what about the root of a complex number is that if one of the roots is 2 minus iota, then the other root will be 2 plus iota. So we can also substitute 2 plus iota to make the second equation, and then we can solve these two equations simultaneously. So first, expanding this 2 minus iota whole cube, we can first write it as, we can first do 2 minus iota whole square on the side. So 2 minus iota whole square will become 4 plus 4 minus 4 iota plus iota square. Now we know that iota square is -1. So 4 minus 1 will become 3 minus 4 iota. So to find 2 minus iota whole cube, we can write it as 3 minus 4 iota and then multiplied again by 2 minus iota plus a into, we know the expansion of 2 minus iota whole square is 3 minus 4 iota. This will become -6 plus 3 iota plus b is equals to 0. Expanding this, we'll get 6 minus 3 iota minus 8 iota plus 4 iota square plus 3a minus 4a iota minus 6 plus 3i plus b equals to 0. Simplifying, we'll have 6 minus 3i minus 8i, which will become minus 11i. So we can just write minus 11i over here. We know that I square is -1, so this will become -4 plus 3a minus 4ai minus 6 plus 3i plus b equals to 0. In -11 plus 3 will become -8. We can simplify this equation now. 6 and -6 will cancel out. So the term we'll have it -11 plus 3 iota is -8 iota. We can take the 4 on the other side, and on the left hand side we'll have -8i plus 3a minus 4ai plus b, and we can write it as is equals to +4. Now, to find the values of a and b, we can just compare both the sides. So let's put the real terms on one side, 3a plus b, and the complex term, and we can just take iota common. So we can write it as plus. So this will become, and okay, so iota is common, so we'll write it as plus iota, and in the bracket we'll have -8 minus 4a is equals to 4. Now on the right hand side, we have a real term 4 and we don't have a complex term, so we can write it as 0i. So now if we compare, we'll get 3a plus b is equals to 4 and -8 minus 4a is equals to 0. So 4a will be is equals to -8 and a will be is equals to -2. Once we have the value of a as -2, we can write it over here. 3 into -2 plus b is equals to 4. So b will be is equals to, this will become 4 and this is -6. So that will become a +6. And the value of b will be, b is equals to +10. So the values of a and b will be, a will be -2 and b will be +10. In part 2, it says, on a sketch of an Argand diagram, shade the region whose points represent complex numbers z, satisfying both the inequalities z minus u modulus is less than 1 and z less than z plus iota, z is less than z plus iota. Now, what we should know is that what this actually means is that the distance of z from this complex number u is less than 1. So we already know what u is, and that is 2 minus iota. So 2 minus iota will be, so let's say this is 1, this is +2, and -1 is over here. So this is where the point is. This is where the complex number u is, and z is at a distance which is within 1 cm of this. So we'll make a circle of radius 1 centimeter. Okay, and let's try and make it a bit more accurately. So if we make a circle of radius 1 centimeter, this is what it will look like. And we know that this point will be 3, this point will be 1, and this point will be -2. And it also says that z is less than z plus iota. Now, to make this, what we know is that the distance of z from the origin, because we don't write z minus 0, but this actually means that the distance of z from the origin and the distance of z from plus iota. So we can write it as minus iota to understand it better. So the distance of z from the point -1. So the distance of z from the point -1 is lesser. So first we'll make a perpendicular bisector. So this line will be passing exactly in between these 2 points. So we have the 2 coordinates. One of them is origin 0 and one of them is -1. And this, the complex number z is closer to this point. So it means we'll have to shade the region which is above the line but within the circle. So the region that we'll shade is this one. Again, if we have z minus u is less than 1, it means that the distance of z from the point u is within 1 centimeter. So first we make a circle of radius 1 centimeter, and then what this means is that the distance of z from the point origin is lesser than the distance of z from the point -1. Using the concept of vectors, when we write it as we say ab, that means b minus a, or we are going from a to b. So when it says z minus origin, so it means from z to the origin. So z must be somewhere above this line as the distance is lesser from the distance of z from this point.